Imagine a cosmic gold rush unfolding above our heads. In the darkness of space, a swarm of autonomous robots clings to a spinning asteroid, drilling into its metallic core in search of unimaginable riches. Some visionaries predict the first trillionaire will be the person who mines asteroids. It sounds like science fiction, but asteroid mining, once a futuristic dream, is fast becoming a real trillion-dollar space industry. Within the next few decades, space robots may unlock precious metals and minerals beyond what's available on Earth, reshaping our economy and our destiny in the process. Asteroid mining is the concept of extracting valuable resources from asteroids, the rocky or metallic remnants of planet formation orbiting the Sun. These space rocks can contain vast deposits of metals such as iron, nickel, platinum, gold, and rare earth elements. Why mine them? Earth's resources are finite, and many high-tech metals are becoming harder to find. In contrast, asteroids offer a treasure trove of materials in a gravity-free environment. Extracting resources in space could provide near-unlimited supplies of critical elements and reduce the need for harmful mining on Earth. Water ice found on asteroids can even be turned into rocket fuel, hydrogen and oxygen, enabling deeper space exploration. In short, asteroid mining matters because it could fuel the future of the space economy and solve resource shortages on our home planet. But asteroid mining isn't just about raw materials. It's about building a space-based economy. Materials extracted from asteroids could be used in space to construct habitats, satellites, and fuel depots, sidestepping the enormous cost of lifting supplies off Earth's surface. By harvesting resources from space, humanity can establish a permanent presence beyond Earth and open a new frontier for industry and exploration. Not all asteroids are created equal. Some are literal gold mines. One famed example is 16 Psyche, a massive metal-rich asteroid orbiting between Mars and Jupiter. Scientists estimate Psyche contains astonishing quantities of iron, nickel, and precious metals. By one estimate, worth around $10,000 quadrillion, that's $10 quintillion, in raw resources. For perspective, that single asteroid's metals far exceed the value of the entire global economy many times over. Psyche is an extreme case, but even smaller near-Earth asteroids can be incredibly rich. A metallic asteroid just 1 kilometer across could hold more than $20 trillion in metals like iron, nickel, and cobalt. In fact, asteroid catalogs suggest there are hundreds of asteroids valued at tens of trillions of dollars each. These cosmic treasure troves include platinum group metals, iridium, palladium, platinum, that are rare on Earth and crucial for electronics, catalysts, and renewable energy technology. A single half-mile-wide asteroid might contain more platinum than has ever been mined on Earth. Such bounty could supply humanity's metal needs for generations, potentially eliminating scarcity for those resources. It's no wonder asteroid mining is often described as a 21st century gold rush, with asteroids as the mother lode. The astronomical economic potential, often quoted in the trillions, has spurred serious interest from both governments and startups, all eyeing a slice of this off-world wealth. Traveling hundreds of millions of miles to mine a rock in space is not a job for humans in spacesuits, it's a job for robots. Robots in space will be the prospectors and miners of the asteroid belt, and automation is the key to making asteroid mining possible. Why robots? For one, asteroids have no gravity and no atmosphere, making them hostile and difficult for humans to work on. Robotic spacecraft, however, can operate in microgravity and survive intense radiation and temperature extremes where humans cannot. They also don't require life support, food, or return tickets home. Perhaps most importantly, distance makes real-time control impossible. An asteroid might be tens of millions of miles away, causing a radio signal delay of 10-20 minutes or more each way. Asteroid mining robots must be highly autonomous, able to make decisions and fix problems on their own. This demands advanced AI and self-repairing systems, a challenge engineers are actively working on. The good news is that many of the core technologies have been developed in labs: drills that work in vacuum, machinery to extract water by heating asteroid rock, optical mining, and robotic arms to scoop up soil. These have proven feasible in experiments. We have the technology, as experts say. It's more a matter of scaling it up and having the will to do so. Several prototype space robots are already laying the groundwork. For instance, a partnership between a UK startup and Japan's Tohoku University developed SCAR-E, a six-legged robotic explorer designed to crawl on asteroids and moons in microgravity. SCAR-E can anchor itself to a surface and take samples, showing how future robotic miners might operate. NASA and other agencies have tested small drills and percussive hammers on meteorite-like materials, while companies are designing asteroid grabbers, spacecraft that could bag a small asteroid and process it internally. In short, autonomous robots, not astronauts, will likely be the ones tapping asteroid riches. A high-stakes race is underway to claim the new frontier of space resources. Which countries and companies are investing in this asteroid mining rush? The United States has been a leader, not only technologically, but also legally. In 2015, the US passed a groundbreaking law granting American companies the right to own and sell resources they extract from asteroids. This clarified that while nobody can claim an asteroid itself as sovereign territory, per the 1967 Outer Space Treaty, private firms can mine and profit from them under US law. NASA, for its part, has run competitions and provided grants for asteroid mining tech. And in 2023, it launched a mission to asteroid Psyche, not to mine it yet, but to study its composition up close. Tiny Luxembourg has emerged as an unlikely pioneer in space mining. The Grand Duchy made a strategic decision to become Europe's hub for asteroid mining by investing heavily in the sector. In 2016, Luxembourg took a major stake in US asteroid mining startup Planetary Resources and set aside €200 million to attract space companies to its shores. It even created a national space agency, and in 2017 passed its own law guaranteeing private companies' rights to space resources they obtain. This forward-looking policy, similar to the US approach, turned Luxembourg into a magnet for ambitious startups in the field. Other nations are following suit. Japan, the United Arab Emirates, and China have all expressed interest in space resources. By 2021, Japan and the UAE adopted laws or policies to support space mining ventures. China, while not openly passing commercial space mining laws yet, is heavily investing in lunar and asteroid exploration technologies. A Chinese private company, Origin Space, launched a satellite in 2020 to test asteroid observation and capture techniques. On the corporate side, the early frontrunners were startups founded around 2012, Planetary Resources and Deep Space Industries. Backed by billionaires and tech titans, these companies sparked the initial asteroid rush. While those first-generation ventures ultimately went bust or pivoted, they proved the concept was serious. Their legacy lives on in a new wave of companies that have learned from early mistakes. Today, several startups are racing to be the first to actually mine an asteroid. One is Astroforge, a US company founded in 2022 with the audacious goal of mining platinum group metals from near-Earth asteroids. In April 2023, Astroforge launched a small demo satellite to test its in-space metal refining technology. Another contender is Transastra, known for its concept of optical mining, using concentrated sunlight to break apart asteroid material and extract volatiles like water. Startups like Carmen Plus and the UK's Asteroid Mining Corporation are also developing robotic technologies. Even established aerospace companies have taken notice, with giants like Bechtel investing early in the asteroid mining concept. If asteroid mining succeeds, the economic implications will be enormous. We're talking about unlocking resources valued in the tens of trillions of dollars, potentially outpacing the GDP of entire countries. One analysis estimates that mining just the 10 most valuable asteroids accessible could yield around $1.5 trillion in profit. As space mining scales up, it might supply raw materials for everything from smartphones to electric vehicles, making high-tech goods cheaper and more abundant. However, such a revolution cuts both ways. An influx of asteroid-derived metals could disrupt global commodity markets. Precious metals that are scarce on Earth, like platinum or cobalt, might suddenly flood in from space, driving prices down. Abundant space resources might undercut Earth-based mining. Imagine the impact on countries whose economies rely on mining exports. Researchers warn that a space mining boom could destabilize developing economies. In other words, asteroid mining could reshape geopolitics, shifting resource power away from traditional mining countries to those with space capabilities. At the same time, Access to space resources could reduce conflict over Earth's resources. Nations might no longer need to compete or go to war over oil, metals, or rare earths if virtually unlimited supplies are available in the asteroid belt. But wealth and power may concentrate with the few players able to harvest space riches, potentially widening the gap between spacefaring nations and the rest. Ultimately, the successful mining of asteroids would signal that humanity's economy is no longer earthbound. It could kickstart a space-based supply chain, asteroid metals fueling giant 3D printers that build satellites in orbit, or water from asteroids sold as rocket propellant. Entire new industries, space construction, off-world tourism facilities, fuel depots could emerge, creating jobs both on Earth and in space. The GDP of the solar system might one day become a meaningful concept. Before this epic vision can become reality, formidable challenges must be overcome. The first is technical. Landing on a fast-moving, irregular space rock and extracting ore in microgravity is extraordinarily difficult. Processing the materials in space will require automated space refineries. As of now, our mining systems are only at technology readiness level, approximately 4 tested in lab but not yet in space. Legal challenges loom just as large. The Outer Space Treaty of 1967 declares that no country can claim sovereignty over celestial bodies. It didn't anticipate private mining missions, so there's a gray area. Is it legal to take resources from an asteroid and sell them? Countries like the US, Luxembourg, Japan, and UAE have answered yes. But some officials have derided unilateral space mining as cosmic colonialism. Efforts like the Artemis Accords and the Hague Working Group are beginning to outline best practices. The ethical and environmental questions are equally pressing. Should space resources belong to all humanity? Should profits be taxed or shared? Could mining damage scientific exploration or create space debris? Some propose setting aside space wilderness areas for protection. On the flip side, space mining could reduce environmental damage on Earth by replacing terrestrial mining. Bold, dramatic, and unprecedented, asteroid mining truly feels like science fiction becoming reality. We stand at the edge of humanity's next frontier in space, where space robots and prospectors venture into the unknown, chasing fortunes in the stars. The Trillion-Dollar Asteroid Mining Rush promises not only wealthy rewards for those daring enough to lead it, but also a fundamental shift in our civilization's trajectory. Picture a future where off-world mines supply the metals for our cities, where fuel from asteroids powers rockets that routinely traverse the solar system, and where economies on Earth and in space are intertwined. The rush for asteroid riches, valued in trillions, could indeed remake our economies and redefine geopolitical power. But it also represents something deeper: the innate human drive to explore, innovate, and push beyond boundaries. As we watch robots in space inch us closer to this once mythic goal, one thing is clear: the future of the space economy will be forged not just on Earth, but in the minds of the final frontier.